First thing I'm going to say really with these types of questions is you definitely got an advantage if you've got familiarity with the function itself. Not essential. Um, and the other thing I'll add, just to reassure you, with all of these functions, by definition, you must be given the domain. But I'm just going to mention, in an ideal world, I'll look at this function. I'll see it's a straight line, and so I'll know potentially this could take anything between minus infinity and infinity as its domain. With this one, it's the same. It could take anything between, it's a quadratic, and it could take a domain of anything between minus infinity and infinity. At this point, again, as I say, although you'll be given the domain, what I can see straight away though is that the domain must be greater than 2, because I know about the square root function. I know this must be a positive, and the only way that can be a positive is for x to be greater than 2. Again here, as far as the domain is concerned, reciprocal graphs, we can never have a fraction with 0 underneath it. So everything is fine here except the value of when x is equal to 2, so that definitely can't be included in the domain. E to the x can take anything between minus infinity and infinity as its domain, and the logarithm function, again, is unusual. It must be strictly greater than 0. Now, you'll need to understand this not for the basic equations where you're simply asked, or the basic questions where you're simply asked to find the inverse, but when you come on to the more difficult questions, when you're asked to find about composite functions, then in those situations you're going to have a good idea what the domain of these functions could be. However, for the straightforward questions, you'll be given the domain. So all you're left with to find is the range. And one of the methods that you can use is simply substitute it in the extremes of the domain and see what you get. And I've seen you do this, so I know that you know what you're doing in that respect. Again, in an ideal world, you'd be so familiar with these functions, you'd just be able to know what's going on. So for instance, if I gave this here as a domain that x is less than minus 2, I would know, right, well, I can see this is a quadratic, and I can see this is what it's going to look like. It's going to cross there, and minus 2 squared is 4 plus 6, so I know that that value there would be a height of 10, and so I can see that it's going to be, this is going to be the range. X is going to be greater than 10. But you can do it, just that sort of way. I'll substitute in the extreme, so the smallest this can be is minus 2, so I'll substitute minus 2 in and I get 10, and the largest this can be is infinity, so we take a very large number, and infinity squared is going to be infinity. So you can work it out that way, fine. And again, with these, you can work out the range in exactly the same way. Just substitute in the smallest value of x that x can take and see what that is, and the largest value that x can take and see what that is, and you'll get your range that way. And in C3, that will always work. It wouldn't work, generally in maths if you went beyond, A level, but for this, in this case, it will work. The next thing we're going to come on to is just undoing a square. Now, I know we've talked about this, so you'll be on the ball. The minute I see it's a square root, I just know what's going to happen. In these types of questions, most of the marks come with the algebra. Can you actually find the inverse function? So don't get too obsessed about, worried, I suppose, about domains and ranges. There are marks attributed to it, but the bulk of the marks are here. And then this is the sticking point, because to undo a square, I always have to take a positive and a negative square root. So this is our problem. We've got a positive and a minus. Now what I should have done, which I didn't do, is give you the less than 0. Now if that's the domain, then automatically I don't need to do anything else. I'll just put x is less than 0. You've got to be skilled in finding the range. So we'll do the range, and if x is less than 0, again you can substitute in the extremes, but you're going to find that the range is x is greater than 6. So the range here becomes the domain here. So x is greater than 6. Now the point is, you can just do it one of two ways here. You can see that this as a whole has always got to be a negative, and the only way I can make that happen is by forcing this to be a negative. But if you just want to try it out, you can choose a value. Let's pick any value of x that fits the domain. So let's say, well, a number greater than 6, let's say 10. So I'll substitute that in. And I've got a choice, but when I look at the range, it's got to be less than 0. So I've got to pick this value, and consequently I know that it's always going to be the minus in that case. Just going to talk about composite functions, and this is really what I'm showing you here is a way to lay it out. G of x is being fed into f of x, so I'm going to start on one line with g of x, and what I should do here actually is put in my domain in both cases, and this is going to be, so I'm going to put in what I'm feeding into g of x, which is 0 and infinity. That goes in, and what comes out, and this is where you need your knowledge of being able to find the range, is going to be between minus infinity and plus infinity. Again, to find the range, you can either substitute in, now remember this is strictly greater than 0, so we can put 0.0001, and you'll find it's a very negative number, so you know it's going to be negative infinity. And again, we can put a very large number in at the other end, and you get a large number out, so it indicates to you that it's going to be infinity. Or in an ideal world, you know, I know all about the logarithmic function, and I can see the range is between minus infinity and plus infinity. This is the trick. Now, staggered, I'm going to put f of x. I'm going to do the same. What again is feeding in is minus infinity to plus infinity. And the point is here, there is a match. You know, there's no restrictions. Based on what I feed into here, what comes out is this, and it can go straight across, no problems. So this takes in the full interval that it could have taken, and consequently what comes out is its full range, no problems. I know you can work this algebra exercise again, you know, is where the bulk of the marks is going to be, and you're just going to substitute g of x into f of x, and I know you won't have a problem with that. But let's have a look if it's g f of x. I'm going to lay it out exactly the same, except I'm feeding f of x into g of x. So I'll put my f of x, and what's going in is this domain, and consequently what comes out, and again this is what the skill is, working out the range, is going to be minus infinity to infinity. And then I stagger just as before, so I'll put my g of x here, put my range, what can come in, 0 and infinity. And this is where we have the problem now, because what's being delivered is between minus infinity and infinity, but this can only accept greater than 0 up to infinity, so we have got a mismatch. This is a problem. So what we need to come out of here is 0 to infinity. So we've got f of x, and we need the output to be greater than 0. So we need it to be greater than 0. And if I solve this, I'll get x is greater than minus 7 over 2. So that's the domain that I need for my composite function. I need to change this to x is greater than minus 7 over 2. And that being the case, if I feed any value greater than minus 7 over 2, then the new domain becomes between 0 and infinity, and so it matches. And feeding that in, I check what's the range of this function when the domain is between 0 and infinity, and I get minus infinity and infinity. So that's my new function, and its domain will be x greater than minus 7 over 2, and its range minus infinity to infinity. But lay it out like this and you can see what's going on.